All right, let's get right into it. Today, we're exploring the incredible and kind of complex chemical story of your brain on drugs. We're going to look at everything from that coffee you had this morning to some really powerful opioids and see how they interact with the amazing wiring inside your head. So, here's a question for you. What could your morning coffee possibly have in common with something like methamphetamine? It sounds like a trick question, right? But the answer really gets to the heart of what we're talking about today. It's all about how they both, in their own way, hijack your brain's very delicate chemical balance. And in this explainer, we're going to unpack exactly what that means. You can think of your brain as this super fast, super complex communication network. Everything you think, everything you feel, everything you do, it's all because of these tiny chemical messengers, neurotransmitters, that are zipping signals between cells. Well, psychoactive substances are like master hackers. They get into that system and start altering the signals. And we can basically group them into three main categories based on how they go about changing those messages. Okay, so let's jump into our first category, stimulants. You can probably guess from the name, these are the substances that put your brain and your body into overdrive. They're basically slamming the accelerator on your central nervous system. Now, here is the most important thing to get about stimulants. They don't actually create new energy out of thin air. Nope. They just push your existing systems to run way faster and harder. So think of it like hitting the fast forward button on your brain's battery pack. And this really shows you the massive range we're talking about. On one end, you've got caffeine. Here's a cool little tidbit. Caffeine works because its shape is almost identical to a chemical in your brain called adenosine, which is what makes you feel tired. It literally slides into the adenosine's parking spots and blocks it. Then, on the other extreme, you have something like cocaine, which just unleashes a massive flood of the pleasure chemical dopamine, but carries these huge, life-threatening risks. All right, so let's shift gears and head to the complete opposite end of the spectrum. Let's look at how depressants work. If stimulants are the gas pedal, these guys are the brakes. So that slowing effect is exactly why they're often used for things like anxiety or tension. They just quiet the noise. But, and this is a big but, that very same function, slowing everything down, is what also makes them so incredibly dangerous. And here we see two totally different ways to slow the system down. Alcohol, for instance, works by boosting something called GABA, which is basically your brain's main off signal. It's the primary brake pedal for your brain. Opioids, though, they do something different. They mimic our body's own natural painkillers, but they are so powerful they can slow down absolutely essential functions, like your breathing, sometimes to a complete and fatal stop. And now for our final category. This group is, well, it's different. These substances don't just speed you up or slow you down. They can fundamentally change your entire perception of reality itself. These drugs, which you might know as hallucinogens, mostly work on the serotonin system in your brain. And you can think of serotonin as kind of a master regulator for your mood, your senses, your thoughts, the whole shebang. So by messing with this system, psychedelics can essentially scramble all the data your brain is trying to process. What's really interesting here is that the effects are super personal and subjective, and the biggest risks aren't usually a physical overdose, like we see with opioids. Instead, the danger is profound and sometimes terrifying psychological distress, things like paranoia and really intense, lasting anxiety. So we've seen how these substances can speed up, slow down, or just completely remap how the brain works. But what happens when the brain gets repeatedly pushed and pulled and twisted by these really powerful chemicals over and over again? Your brain is an absolute master of adaptation. Its number one priority, all day, every day, is to keep everything stable. It's a state called homeostasis. So when a drug constantly throws it off balance, the brain fights back. And this powerful, deep-seated drive for equilibrium, that is the biological root of addiction. And it's a pretty predictable cycle. It all starts with a powerful new effect. But pretty soon, the brain adjusts its own chemistry to fight back against the drug. That's what leads to tolerance. You start needing more to get that same feeling. Then, eventually, the brain changes so much that its new normal is with the drug and it feels completely wrong without it. That's dependence. And of course, when the substance is taken away, the readjusted brain basically goes into a panic, and that's withdrawal. So what's the big takeaway here? It's that the brain's incredible, brilliant ability to adapt and find balance is the very same thing that can trap it in a dangerous cycle of dependence. Understanding these chemical stories helps us see not just the profound risks involved, but also the truly remarkable resilience of the human brain.